Hello everyone, I'm Prakhyath Jain, Assistant Professor, Department of Mechanical Engineering, AJIET Mangalore. Today I'm going to discuss about Module 3 of Fluid Mechanics, that is Class 8, Continued Portion of Fluid Dynamics. So in this video, I'm going to discuss about notches and weirs, discharge through rectangular and V-notch, and related problems. So first let's go for defining what are notches and weirs. So a notch is a device used for measuring rate of flow of liquid through a small channel or tank. So compared to venturi meter, orifice meter and pitot tube, those are the devices that those are used to measure discharge of flowing fluid through a pipe. But these notches and weirs that can be used to measure the rate of flow of a liquid through a small channel or tank. So that means it is related to measurement of discharge of open channel or open tank. So the notch may be defined as an opening in the side of tank or small channel in such a way that the liquid surface in the tank or channel is below the top edge of the opening. So you can see the diagram here. So there is an opening in the tank at the side, like it is a sideway opening. The notch may be defined as opening in the side of tank or small channel in such a way that liquid surface in the tank or channel is below the top edge of the opening. So you can see the water level in the tank, it is below the top edge of the opening, and it is the opening in the sideway. So this is a definition of notch. It is a small opening in the side of tank or open channel. So level of liquid should be below the top edge of opening. So you can see here, this is V-notch. So what is the difference between rectangular notch and V-notch? So for rectangular notch, the shape of this opening should be rectangle, whereas for V-notch, or it is called as triangular notch, the opening is in the shape of triangle or V shape. There is an angle theta in between the opening. So this is a diagram of V-notch or triangular notch. So let's go for defining what is weir. So weir is a concrete or masonry structure placed in an open channel over which flow occurs. So you can take consideration of a dam, the water flowing over the dam. So this is an example of weir. So it is a concrete or masonry structure. So dam that we are going to construct using bricks and concrete. So same way weir also it is a concrete or masonry structure placed in open channel over which flow occurs. So liquid is flowing over that structure. So but in case of notch, the liquid is flowing through the opening. Here it is flowing over the structure. So it is generally in the form of vertical wall. So it is just like a wall structure with a sharp edge at the top running all the way across the open channel. So it's like dam like structure. It is made up of concrete or masonry structure. So it is constructed across the open channel. The notch is of small size while weir is of bigger size. So notch, it is a small opening, whereas weir is a bigger size. It is of bigger size because it is a concrete structure and it is constructed across open channel. So notch is generally made up of metallic plate. So there's a difference. If they are going to ask differentiate between notch and weir, you can write for notch it is a small opening, whereas the weir is the concrete structure. It is constructed across open channel. So again the notch is made up of metallic plate, whereas the weir is made up of masonry structure or concrete. So that's the differences. So notch is generally made up of metallic plate. First one, there are some basic definitions with respect to weir and the notches. So first one, nappy or veen. So what is nappy or veen? So sheet of water flowing through a notch is called nappy or veen. So sheet of water flowing through a notch. So you can see the diagram here, sheet of water flowing through a notch. First diagram you can see there. So it is flowing over the opening. Or sorry, it is flowing through the opening. So whatever the sheet of water that is flowing through the opening, that is called as nap. So otherwise for it with respect to weir is a sheet of water flowing over the weir. So there's a basic definition of nap or veen. So it is a sheet of water flowing through a notch. It is for a notch and for where it is the sheet of water flowing over where. So it is called as nappy or nap or veen. So second one, crust or sill. So the bottom edge of notch over which water flows is known as sill or crust. That is with respect to notch. The bottom edge of notch over which water flows is known as sill or crust. While for with respect to where is a top edge of where over which water flows, because water is flowing over where in case of weirs, but in case of notch the water is flowing through the opening. So bottom edge of notch over which water flows is known as sill or crust. So you can see the diagram here. So nap I already explained is a sheet of water flowing through notch, or it is the sheet of water flowing over notch. You can see the second diagram where so water is flowing over the concrete structure. So next, crust is the bottom edge of the opening over which or through which the fluid is going to flow, but in case of weirs it is the top edge over which the liquid is going to flow. So that is the difference you have to know. Notch is, you just remember like this, notch is a small opening through which the fluid is going to flow, but in case of where it is like liquid is flowing over the where, because it is similar to dam construction. You just remember example for whereas dam, so there is a water flowing over that dam, so that is the example for just where. So notch, so basic definitions, nap and this one, what is that, sill, you have to just remember nap or veen, crest or sill. So the basic definitions. So classification of notches. The notches are classified according to the shape of opening as first one rectangular notch, second one triangular notch, third one trapezoidal notch, and fourth one step notch. Depending on shape of opening, they are classified as rectangular notch, triangular notch, trapezoidal, and step notch. So rectangular notch means it is opening is in the shape of rectangle. Triangular means it is in the shape of V or triangle. Trapezoidal, it is in the shape of trapezoid. And stepped, you know what how exactly the step notch looks like, because you already studied about step bars and all. It is the step notch. So let's go for derivation. Discharge over a rectangular notch or wear. The expression for discharge over rectangular notch or wear is the same. So there are like the expression for discharge, there's a quantity of water flowing per second that remains same for rectangular notch or wear. So consider a rectangular notch or wear as shown in figure. You can see the diagram there. So rectangular notch and rectangular wear. So rectangular wear, it is a quantity of water flowing over the wear, whereas rectangular notch is a quantity of water flowing through opening. So you can just see the diagram there. So there is a rectangular notch that is represented in or shown in diagram A, and there is a rectangular wear that is shown in diagram B. So let H is the H equal to head of water over the crust. So you can see there H, capital letter H, there is a head of water over the crust, or head of water flowing over the wear, or head of water flowing through notch. Let L equal to length of notch or wear. So it is a length of notch or wear. For finding the discharge of water flowing over the wear or notch, consider an elementary horizontal strip of water of thickness dh and length L at a depth h from free surface of water as shown in figure C. So you can see there, you have, in order to derive or to get the expression for discharge, we have to consider water, horizontal strip of water, there's a thickness dh, and its distance from free surface is a small letter h, and length of that strip is capital letter L, that is shown in figure C. So the area of the strip, so that is equal to thickness into length. L into thickness is dh, so L into dh. And theoretical velocity of water flowing through strip. So theoretical velocity, I already discussed about this thing in Pitot tube. Theoretical velocity or ideal velocity. So without coefficient of velocity, that is without CV. So that is equal to square root of 2gh, where g is acceleration due to gravity, h is the surface it is a distance from free surface to the horizontal strip. So the discharge dq through strip is given by, q equal to AV, area into velocity. So here we consider one small strip, so discharge becomes dq. Small strip means small discharge, that is dq. dq equal to CD into area of the strip into theoretical velocity. Now why this CD? So because we are going to find out here actual discharge. It is not theoretical discharge. So I have to multiply CD here for dq, small letter dq. So dq equal to CD into area of strip into theoretical velocity. So that is equal to CD. Area is length into dh. So CD into L into dh, and theoretical velocity is square root of 2gh. Take it as expression 1. Now the total discharge Q for the whole notch or weir is determined by integrating equation 1 between the limits 0 and h. So therefore Q equal to, in order to get total Q or total discharge, we have to integrate between the limits 0 and h. That's a capital letter H. You can see there the limit for that is the head of water. It is capital letter H over the notch, over the weir, or the water head of water flowing through notch. So capital letter H, small letter h is the distance from free surface of water to horizontal strip. So integrate the dq expression in between 0 and h limits. So q equal to integration from 0 to h CD into L into dh into square root of 2gh, that is equal to CD into L into square root of 2g. So just split square root of 2gh because the other term that is square root of 2g, that is a constant, we can remove from integration sign. So CDL and square root of 2g, that is constant, I can take that thing from integration sign. So integration multiplied by integration 0 to h into square root of h. What is square root of h? Square root of h is h to the power 1 by 2. So integration 0 to h to the power 1 by 2 dh. So that is equal to CD into L into square root of 2g into integration of h to the power 1 by 2, that becomes h to the power 1 by 2 plus 1 divided by h to the divided by 1 by 2 plus 1. So it is a power h to the power 1 by 2 plus 1 divided by 1 by 2 plus 1, integration limit from 0 to h. Now that is equal to CD into L into square root of 2g. Now h to the power 1 by 2 plus 1, that becomes h to the power 3 by 2. So similar way, denominator also 1 by 2 plus 1, that is 3 by 2. So integration limit from 0 to h. Now just apply the integration limit. So q equal to 2 by 3 CD. So 3 by 2, that goes to numerator and becomes 2 by 3. So q equal to 2 by 3 CD into L into square root of 2g s to the power 3 by 2, that is a small letter h. So it becomes capital letter H upon applying limit. So s to the power capital letter H to the power 3 by 2. Q equal to 2 by 3 CD into L into square root of 2g into s to the power 3 by 2. So that is an expression for discharge for rectangular notch or rectangular weir. Now let's go for discharge over triangular notch or weir. So the expression for discharge over a triangular notch or weir is the same. It is derived as let h equal to head of water above V notch. So the expression for discharge that remains same for triangular notch or triangular weir, that is one and the same. You can derive that expression for one case, triangular weir, a notch or triangular weir. So let h equal to head of water above the V notch. Consider a horizontal strip of water of thickness dh at a depth of h from the free surface of water as shown in figure. So you can see the diagram. The capital letter H is the head of water over the notch, and consider a strip, horizontal strip of water, that is small letter dh of thickness dh at a distance small letter h from free surface of water. You can see that notation there, small letter h from free surface of water to the surface of horizontal strip. So there's a diagram. Angle of that notch is theta because this is triangular in shape. So angle is theta between the two opening sides. It is theta. So from figure we have, so we can apply tan theta by 2 there. So for the triangle AOC, you can see the triangular AOC, and from diagram So AOC tan theta by 2. Tan theta by 2 is opposite by adjacent. So what is opposite for theta by 2? Theta by 2 it is AC, and adjacent it is OC. So what is OC now? Just see the diagram. OC. So OC total distance is capital letter H. That is the head of water, capital letter H. And you are going to consider one strip from that is at a distance H from free surface of water. Now what is the height of that is OC? So that is capital letter H minus H, small letter h. So capital letter H minus H, that is the height of the small element, or the triangle, that is the OC. So tan theta by 2 equal to AC divided by OC. So that is equal to AC divided by OC, it is H minus H. Therefore AC equal to, just cross multiply, H minus H into tan theta by 2. So width of strip, now you can see the width of strip. Width of strip is AB. So but we calculated AC. Now width of strip AB equal to 2 times of AC. We have expression for AC, just multiply 2 because it is at the center. So AB equal to 2 times of AC. So width of strip equal to AB, that is equal to 2 times AC, that is equal to 2 into H minus H into tan theta by 2. Therefore area of the strip, that is equal to 2 into H minus H into tan theta by 2 dh, that is a thickness into width. Area of the strip, thickness is dh. We already consider one small element of water, that is dh. So thickness we have, width we calculated, just now we calculated, that is 2 into H minus H into tan theta by 2. So area of the strip equal to 2 into H minus H into tan theta by 2 into dh. Then the theoretical velocity of water flowing through the strip, that is equal to square root of 2gh. So it is a small letter h, just remember this is not capital letter h, it is with respect to small element. So therefore discharge dq through the strip is given by dq equal to cd into area of the strip into theoretical velocity. Cd, that is for again calculating actual discharge. So dq equal to cd into area of the strip is 2 into h minus h into tan theta by 2 into dh, and theoretical velocity, that is square root of 2gh. So dq equal to cd into 2 into h minus h into tan theta by 2 into dh into square root of 2gh. So that is equal to 2 cd h minus h tan theta by 2 square root of 2gh into dh. So therefore total discharge q. So this is again similar to rectangular notch at integrate between the limits 0 and capital letter H. So therefore q equal to integration from 0 to h 2 cd h minus h tan theta by 2 square root of 2gh into dh. Now 2 cd tan theta by 2 square root of 2g. So that is constant, we can remove from integration sign. So q equal to 2 cd tan theta by 2 into square root of 2g. So that is into multiplied by 0 to h, that is capital letter H, into h minus h into s to the power 1 by 2 dh. So s to the power 1 by 2, that is from square root of 2gh. I removed square root of 2g, that is a constant, from integration sign. So remaining is s to the power 1 by 2. So h minus h into s to the power 1 by 2 into dh. Now I forgot to explain about this theta by 2 concept. So total angle is over there is theta. So we are considering one small strip at the center. So angle gets divided by 2. So that is theta by 2. So that is a theta by 2. So that is for triangle, there's the angle AOC, that becomes theta by 2 because we are considering, or we are going to consider small element at the center. So that is angle is theta by 2. So 2 cd into tan theta by 2 into square root of 2g, integration from 0 to h. Now integration of h with respect to capital, just multiply h to the power 1 by 2 inside. So when h to the power 1 by 2 gets multiplied inside, it becomes capital letter H into h to the power 1 by 2 minus h into h to the power 1 by 2. So that is h to the power 1 plus h to the power 1 by 2. So that becomes h to the power 3 by 2. So integration 0 to h, capital letter H into h to the power 1 by 2 minus small letter h to the power 3 by 2 dh. So that is equal to 2 cd tan theta by 2 square root of 2g. Now what is the integration of capital letter H? So capital letter H, it is a constant. So keep as it is. Now integration of h to the power 1 by 2, that is small letter h to the power 1 by 2. So that becomes h to the power 1 by 2 plus 1 divided by 1 by 2 plus 1. So I write directly here s to the power 3 by 2 divided by 3 by 2 minus what is the integration of s to the power 3 by 2? This is a small letter s to the power 3 by 2. So s to the power 3 by 2 plus 1 divided by 3 by 2 plus 1. So it becomes s to the power 5 by 2 divided by 5 by 2. So integration limits from 0 to h. So q equal to 2cd into tan theta by 2 square root of 2g. Now 3 by 2 that goes to numerator and becomes 2 by 3. So 2 by 3 capital letter H into upon applying limit small letter h becomes capital letter H. So capital letter H into capital letter H to the power 3 by 2 minus. So 5 by 2 goes to numerator and becomes 2 by 5 and s to the power 5 by 2. So that is equal to 2cd into tan theta by 2 into square root of 2g into 2 by 3 h to the power 5 by 2. So h into s to the power 3 by 2. So that is s to the power 1 plus 3 by 2. That becomes s to the power 5 by 2. So 2 by 3 into s to the power 5 by 2 minus similarly 2 by 5 into s to the power 5 by 2. So s to the power 5 by 2 is common there. So I can take LCM. So q equal to 2cd tan theta by 2 square root of 2g into h to the power 5 by 2 into 2 by 3 minus 2 by 5. So LCM that is 15. So q equal to 2cd tan theta by 2 square root of 2g into h to the power 5 by 2 into 10 minus 6 divided by 15 upon taking LCM. So that is equal to 2cd tan theta by 2 square root of 2g into 10 minus 6 that is 4 divided by 15. 4 by 15 s to the power 5 by 2. So s to the power 5 by 2 is a capital letter s to the power 5 by 2. Therefore q equal to, so 2 into 4 divided by 15 that becomes 8 by 15 into cd tan theta by 2 square root of 2g into s to the power 5 by 2. So that's the expression for discharge. For right angled V notch, if CD equal to 0.6, so if coefficient of discharge that is equal to 0.6, theta equal to 90. So it is a right angled V notch. Right angle means 90 degree, theta equal to 90. So tan theta by 2, that is 90 divided by 2, that becomes tan 45. So tan 45 is 1. And substitute CD equal to 0.6. So tan theta by 2 equal to 1. Therefore discharge Q equal to 8 by 15 into CD. CD value is 0.6 into square root of 2g into s to the power 5 by 2. Square root of 2g also you can substitute. You can calculate 2 into 9.81 and take the square root. And we are going to get expression as 1.417 s to the power 5 by 2. So that is for right angle V notch. If CD equal to 0.6 and theta equal to 90 degree, right angle just remember it is 90 degree. So theta equal to 90 degree, theta by 2 becomes 45. Tan 45 is 1. So and CD value is just substitute 0.6 and square root of 2 into 9.81. So you are going to get 1.417 s to the power 5 by 2. That is a simplified version. So let's go for problem. First problem, find the discharge of water flowing over a rectangular notch of 2 meter length when the constant head over the notch is 300 mm. Take CD equal to 0.60. So here very important thing, you have to remember formula. So length of the notch, that is capital letter L equal to 2 meter. It is given in problem. So head over the notch, that is capital letter H. Head over the notch, there is a amount of water flowing over the notch or through notch. So head over the notch, capital letter H equal to 300 mm. So that is equal to 0.3 meter. So there is a 300 mm. Just make a correction there. 300 mm. So capital letter H equal to 300 mm. That is equal to 0.3 meter. So CD equal to 0.60. It is given in problem. Therefore discharge, there is an expression for discharge. Q equal to 2 by 3 CD into L into square root of 2G into S to the power 3 by 2. So that is equal to 2 by 3 into 0.60 into 2 into square root of 2 into 9.81 into 0.3 to the power 3 by 2. H value is 0.3 and G value you can substitute 9.81. So that is equal to 0.582 meter cube per second. This is a discharge. The unit is meter cube per second. That is the SI unit. So simple problem. You have to remember one equation for that is for rectangular notch. 2 by 3 CD into L into square root of 2G into H to the power 3 by 2. So discharge value is 0.582 meter cube per second. Now second problem, determine the height of rectangular weir of length 6 meter to be built across a rectangular channel. The maximum depth of water on the upstream side of Weir is 1.8 meter and discharge is 2000 liters per second. Take CD equal to 0.6 and neglect end contractions. So this problem is related to rectangular Weir of length 6 meter to built across rectangular channel. So it is built across rectangular channel. That's an open channel. The maximum depth of water on the upstream side of the Weir. So upstream side of the Weir, you can see there upstream side means to the left of that construction. So that is maximum depth of water on the upstream side of the Weir is 1.8 meter. That is capital letter H1 is 1.81. 8 meter. So maximum amount or maximum depth of water. Next, and discharge is 2000 liters per second. That is capital letter Q. CD value it is given as 0.6. So solution, better it is to you can draw the diagram. It is better to draw the diagram, otherwise it is difficult to understand the concept. So capital letter H1 is the maximum depth or maximum amount of water. So the small letter capital letter H, that is the head of water flowing over Weir. So remaining H1 minus H, that is H2. So that's the distance you are supposed to find. Capital letter H2. Determine the height of rectangular Weir of length 6 meter. So height you are supposed to find. The height of that Weir, you can see there the height of Weir, that is H2. That is H1 minus H. So but from formula you can calculate H, capital letter H. By using that, and H1 it is given in problem. So H1 minus H, you are going to get H2. It is better to draw the diagram here. So length of the Weir, L equal to 6 meter, depth of water H1 equal to 1.8 meter. Discharge Q, that is equal to 2000 liter per second. So you know how to convert from liter per second to meter cube per second. 2000 into 10 to the power minus 3. So that becomes 2 meter cube per second. CD value it is given as 0.6. So let H is the height of water above the crest of Weir. That's what I defined, or head of water. And H2 height of Weir. That one you are supposed to find. So discharge Q, capital letter Q equal to 2 by 3 CD into L into square root of 2G into S to the power 3 by 2. So discharge it is given. So 2 equal to 2 by 3 into 0.60 into length it is 2 into square root of 2 into 9.81 S to the power 3 by 2. So 2 equal to 10.623 into S to the power 3 by 2, or S to the power 3 by 2 equal to 2 divided by 10.623. Now you have to remove that 3 by 2. So that can be done by taking root. So that is H equal to 2 divided by 10.623 to the power 2 by 3. So that is because S to the power 3 by 2, that has to be cancelled. That can be cancelled by multiplying to the power 2 by 3. So that by multiplying 2 by 3 you can cancel 2 and 3. So remaining power is 1. So if you are going to multiply to the power 2 by 3, then you have to multiply to other side as well. So it becomes 2 divided by 10.623 to the power 2 by 3. So that is equal to 0.328 meter. Therefore height of Weir, that is S2 equal to H1 minus H. That is equal to 1.8. It is given H1 maximum depth of water 1.8. H you calculated, that is 0.328. So 1.8 minus 0.328, that is equal to 1.472 meter. So that is the height of Weir. Third problem. This problem is related to triangular notch. Find the discharge over a triangular notch of angle 60 degree when the head over the V notch is 0.3 meter. Assume CD equal to 0.60. So triangular notch of angle theta it is given as 60 degree. So theta equal to 60 degree. Head over the V notch, that is capital letter H equal to 0.3 meter. Assume CD equal to 0.60. So we are supposed to find capital letter Q. So head over the notch H equal to 0.3 meter. Angle of V notch theta equal to 60 degree. CD equal to 0.60. Discharge Q equal to 8 by 15 into CD into tan theta by 2 into square root of 2G into S to the power 5 by 2. So this formula you are supposed to remember here also. Rectangular notch and triangular notch. So discharge Q equal to 8 by 15 into 0.6 into tan theta by 2. Theta value is 60. It is given in problem. So tan 60 divided by 2 into square root of 2 into 9.81 into 0.3 to the power 5 by 2. So that is equal to 0.040 meter cube per second. Tan 30 you can calculate by using calculator. So tan 30. So and the remaining terms, that is just multiplication. So you're going to get a value of Q as 0.040 meter cube per second. So that is the value of discharge. Next problem, fourth problem. Water flows through a triangular right angled weir first and then over a rectangular weir of 1 meter width. The discharge coefficient of triangular and rectangular weirs are 0.6 and 0.7 respectively. If the depth of water over the triangular weir is 360 mm, find the depth of water over the rectangular weir. So this problem is a combination of triangular notch, triangular right angle notch, and triangular right angled weir and rectangular weir, combination of those two, rectangular and triangular. First, the water is going to flow over the triangular weir, then from triangular weir to rectangular weir. So triangular weir depth of water, it is given, that is 360 mm. So we are supposed to find depth of water for rectangular weir. So initially water flows through a triangular weir. From triangular weir it is going to flow over rectangular weir. So head of water for triangular weir it is given, so that is 360 mm. You are supposed to find head of water over rectangular weir. So coefficient of discharge separately it is given for triangular and rectangular weir. For triangular weir it is 0.6 and rectangular weir it is 0.7. First we need to understand the concept. First we need to apply discharge formula for triangular weir. So it is given right angled weir, that means theta equal to 90 degree. So solution for triangular right angled weir, theta equal to 90 degree, CD equal to 0.6, H equal to 360 mm, or that is equal to 0.36 meter. For rectangular weir, length it is given, you can see there, the discharge coefficient, if the depth of water over the triangular weir is 360 mm, okay, it is given. So length equal to 1 meter, so that is then over a rectangular weir of 1 meter width it is given. CD equal to 0.7, so CD value for rectangular weir, and capital letter H you are supposed to find. So instead of getting confused, you can replace capital letter H by H1 for rectangular weir. I use that symbol in formula. Just remember that, otherwise you are going to substitute same value 360, then you are going to end up with nothing. So the discharge for a triangular weir is given by discharge Q equal to 8 by 15 CD tan theta by 2 into square root of 2g into h to the power 5 by 2. So that is equal to 8 by 15 into 0.6 into tan theta by 2 into square root of 2 into 9.81 into 0.36 to the power 5 by 2. So tan 90 by 2, that is tan 45, that value is 1. So Q equal to 8 by 15 into 0.6 into tan theta by 2 into square root of 2 into 9.81 into 0.36 to the power 5 by 2. So that is equal to 0.1102 meter cube per second. The same discharge is passing through rectangular weir. So this is this you have to understand properly. So whatever the amount of water that is flowing over triangular weir, that is going to flow over the rectangular weir. So discharge remains same. So discharge value we got it as 0.1102. So if you are going to make any mistake in discharge calculation, then you are going to end up with wrong result for rectangular weir as well. So discharge Q equal to 2 by 3 CD into L into square root of 2G into h to the power 3 by 2. So discharge value it is same, 0.1102, that is equal to 2 by 3. CD value it is given for rectangular weir as 0.70. So 0.70 into 1 into square root of 2 into 9.81 into h to the power 3 by 2. So h to the power 3 by 2, or you can replace by h1 to the power 3 by 2 in order to avoid confusion. So that is equal to 2.067 h1 to the power 3 by 2. So h1 to the power 3 by 2 equal to 0.1102 divided by 2.067, so that is equal to 0.0053. Just take a root, that is 2 by 3. So because you have to consider 3 by 2, similar to previous problem, h equal to 0.0533 to the power 2 by 3. So that is equal to 0.1415 meter. So that is equal to 141.5 millimeter. It is left to you. Again, I am repeating here. You can write in terms of meter. If you have any doubt, you don't proceed further. Like don't write in terms of millimeter. If they are going to ask only, if they ask in question, then you just convert. 1 meter equal to 1000 mm. So 0.1415 into 10 to the power 3. So that is equal to 141.5 mm. So fifth problem, a rectangular channel 2 meter wide has a discharge of 250 liters per second, which is measured by right angle V notch way. So find the position of apex of the notch from the bed of channel if the maximum depth of water is not to exceed 1.3 meter. Take CD equal to 0.62. So here you just remember, it is again, don't get confused with rectangular channel. Channel is rectangular. There's an open flow area that is rectangular in shape. So it is measured by right angle V notch. So right angle V notch, theta equal to 90 degree. So find the position of apex of the notch from the bed of the channel if the maximum depth of water is not to exceed 1.3 meter. So the same problem I have discussed about this thing. H1 maximum depth of water, that is 1.3 meter. Now head that is flowing over the notch, that is capital letter H. Now you are supposed to find the position of apex of the notch from the bed of the channel. So that means it is the height of the notch you are supposed to find. So that is H2. H1 minus H. So you are going to get H2. So therefore, given data, width of rectangular channel or length, it is given as L equal to 2 meter. So 2 meter, it is given in problem, rectangular channel 2 meter wide. So there is a length L equal to 2 meter. So Q 250 liter per second, convert from liter per second to meter cube per second by multiplying 10 to the power minus 3. So 0.250 into 10 to the power minus 3, that is equal to 0.25 meter cube per second. Theta, right angle notch, so theta equal to 90 degree. Depth of water in the channel, there is a maximum depth, H1 equal to 1.3 meter. So it's better to draw the diagram so that you can understand properly. So CD equal to 0.62, it is given. Therefore discharge for triangular notch, that is Q equal to 8 by 15 CD into tan theta by 2 square root of 2G into S to the power 5 by 2. So Q value we know, so that is 0.25, that is equal to 8 by 15 into 0.62 into tan theta by 2 into square root of 2 into 9.81 into S to the power 5 by 2. So that is equal to 0.25 equal to 8 by 15 into 0.62, tan theta by 2 it is 1 because tan 45, so that is into 1 into 4.429, that is square root of 2 into 9.81, we are going to get 4.429 into square root h to the power 5 by 2. So h to the power 5 by 2 equal to 0.25, just cross multiply 15 divided by 8 into 0.62 into 4.429. So h to the power 5 by 2, that is equal to 0.1707. Now h to the power pi by 2 equal to 0.1707. Now we need h. So that can be done by multiplying to the power 2 by 5. So you have to cancel that 5 by 2. That can be done 2 by 5. So similar way you multiply to the power 2 by 5 on right hand side. So h to the power h equal to 0.1707 to the power 2 by 5, that is equal to 0.493 meter. Now position of the notch apex from the channel bed, or you can just remember as height of that notch. So that is h2 equal to depth of water in the channel, there is a maximum depth, so h1, so minus height of water over v notch, there is a head of water, there is a capital letter H. So h1 it is given as 1.3, h value it is 0.493. So h2 equal to 1.3 minus 0.493, so that is equal to 0.807 meter. So these are the problems related to triangular and rectangular notch. Instead of giving right angle notch, in sometimes they may give the some angle that theta is equal to 60 degree or theta equal to 75 degree. There's a modification you are supposed to do. Rest everything is same. Otherwise they can club together two cases like triangular notch and rectangular notch. I solved problem related to triangular notch and rectangular notch. They can exactly make reverse. There's rectangular notch first, then triangular notch next. So discharge remains same. So you have to assume like that because same water is going to flow from one notch to another notch. So using that you can solve the head of water on like rectangular notch or triangular notch. Okay, thank you.